Make sure you know all the notes that are on these pages I'm giving you. Real quick, regular polygon. That means all the sides and all the angles are equal. We've memorized these 2 degrees. We know that if it's a triangle, that automatically means 180 degrees inside. We've already memorized if it's a quadrilateral, 4-sided figure. That means it's going to have 360 degrees inside. But if it's anything bigger than that, we haven't really memorized it. So we have to use this formula. The degrees inside of a shape, we could use n minus 2 times 180. N being the number of sides. So you used to know that. Just bring it back to the front of your brain. Now, anytime we look at a polygon, it has interior angles. So looking at this pentagon over here, the angles that I'm drawing in red right now, these are the interior angles. And those are the ones that we would use the formula n minus 2 times 180 to find the total of those. But see these numbered angles around the outside? Those are called exterior angles. We don't need a formula to find the sum of those exterior angles because it is always 360 degrees. So just remember that. Now looking at this picture with the triangle and the one exterior angle. So the angle number 1 is an exterior angle. Now looking at angle 2 and angle 3, those are interior angles, but we will call them remote interior angles because they're far away from angle 1. The relationship that you need to know is the sum of the 2 remote interior angles should equal the exterior angle that they are away from. So that's where this is coming from. Angle 1 should equal the sum of angle 2 and 3. Make sure you know that. Obviously that means angle 1 is going to be bigger than either of the angles by themselves because it's the sum. Alright, so with all that in mind, oh yeah, one more thing as far as the notes go. You need to know all of these names. If I say heptagon, you need to know that that's how many sides? 7. So some of you already know them all, but some of you have gaps. Okay, like maybe you didn't know that heptagon was a 7-sided figure. So make sure you study this chart and you know all the names and how many sides they represent. So let's do problem number 1. Find the measure of one interior angle of a regular pentagon. So a pentagon is 5 sides, right? So we can just use the formula. We're just going to use n minus 2 times 180. So for a pentagon, that's going to be 5 minus 2 times 180. Okay? What does that come out to be total? 540. That's 540. Okay? Now that is the total degrees. Okay? Correct. If I want one angle, I'm always going to do it by finding the total degrees and then dividing that by the number of sides. And that's going to give me one angle. Okay? So in this case, if I do 540 and I divide that by 5, that should give me one angle. So what's that going to be? That's 108. Okay? So each angle should be 108 degrees. Number 2, find the measure of one exterior angle. Well, this is a little more simple. We're still doing total divided by the number of sides equals one angle. But I hear John over here saying the total is going to be 360. It says hexagon. How many sides is that? That's 6. So total divided by the number of sides gives you one angle, 60. Okay, so that's your answer, number 2. Look at number 3. Who can tell me the relationship between the interior angle and the exterior angle here? Hint, what should they add up to?
3x.
Well, if I combine them, they make 3x, but I want to know a number. What's right, the total degrees here should be 180. Why? Because it's a straight line. Does everybody see that? This makes a straight line right here. So we use what we've always known about straight lines, total of 180 degrees. That's why I should be able to make this equation. X plus 2x should equal 180 degrees. And I already heard several people telling me, if I combine these like terms, what do I get? 3x equals 180, right? Divide by 3. So what do I get? X equals 60. So that is the interior angle.
60?
Was 60.
I thought it was 108.
We're on number 3.
Yeah, I get that.
Why did you think it was 108?
Because I did 520 divided by 5.
Okay. For people that are listening to this video at home or in another class, she said she was thinking that would be 108 because she did 540 divided by 5. All right? The mistake that you were making was you were assuming that this was a regular pentagon. You were assuming that all the sides and angles would be the same, so you could just take the total and divide by 5. But there's nothing in this problem that tells us that this is a regular pentagon. So we can't just divide by 5. Okay? So instead we had to use this straight line relationship and do the x plus 2x and solve it this way. So we got x equals 60. That's the interior angle. So what will be the exterior angle?
180 minus
180 minus 60,
60. Which is 120.
which is 120. Okay, so that's what we were supposed to find, the interior and the exterior. Any questions? You're frowning. Is there a question in that frown? Are you sure? I've got lots of answers. I'm loaded with answers. The x, okay? Do you understand how I got this equation? Oh, the exterior. There's two ways I could have done it. We know x now, right? X is 60. This exterior angle is 2x. So one way to do it is just to do 2 times 60. What's 2 times 60? 2 times 60, that's your 120. That's one way to think about it. The other way to think about it is straight line. We knew that these would make a total of how many degrees? 180. So once we find one angle is 60, we could find the other angle by doing 180 minus 60, since they have to both add up to 180. And that also is another way of getting 120. Okay?
I'm going to know if it's a regular.
Unless they say that it's regular, do not assume that it's regular. For example, look at problem number 2. Find the measure of one exterior angle of a regular hexagon. It's going to say it right in there if we can assume.
So I could have done what I did if it was regular.
Exactly. In fact, look at problem number 1. That's exactly what we did do for problem number 1. When they said regular, we did do 500 and we did get 108. Okay? Look at number 4. Before I start talking about which sides are the longest and which are the shortest, it would be helpful to know what this missing angle is.
68.5.
All right, I heard this other angle is 68.5. How did she get that?
I added all the other angles and subtracted from 180.
Right, so you have two choices. You can either add the other two angles and subtract from 180, or what's another way I could also do it? Sure, if we already know that it is a right triangle, I could just do 90 minus the other angle. 90 minus 21.5. Either way, you get 68.5. Now, what is the biggest of these three angles? The 90-degree angle is the biggest. So please remember that the bigger angle is always going to be across from the bigger side. So that means the biggest side is going to be CD. Now, read the directions. It said list the length from greatest to least. When we had a test on this unit, I said greatest to least. But about 10 of you put them from least to greatest because you didn't really read the question. You just assume that usually it's the least to greatest, so you just went with that. Please, please, please read the question. If it says greatest to least, it means just that, greatest to least. So that's the biggest. What's the smallest angle? What's the smallest angle? Right, the 21.5 is the smallest angle. So the smallest angle is going to be across from the smallest side. So that means CE is going to be the very smallest. I'm going to put that last. What does that leave for the middle one? That leaves ED for the middle. Okay? So on a test, you'll probably see this written as an inequality. CD is bigger than ED, which is bigger than CE. But that's the order that we'd be looking for. Stop me if you have any questions. It's a sting day, so I'm just going to be kind of rolling along. But if you have a question, I will slow it down for you. Okay? So, looking at number 5. They're talking about triangle ECD. I don't see any triangle. What am I supposed to do? I'm supposed to make one. I'm supposed to draw a picture. So that's another big thing that I'm looking for from you guys, both in your packet and on your scratch paper when you take the actual EOCT. I want to see lots of pictures everywhere, please. So let's go ahead and just draw a triangle real quick. No, it definitely isn't, because look at the angles. Are the angles all the same? What?
Okay, so I drew this, that's okay? Just that thing?
Yeah, just really, you can just draw any old triangle. And don't sweat it. Just drawing not to scale. Trust your numbers. That's the key. I don't need any comment. Okay. So I'm going to have angle ECD. Okay, angle E is 136. Angle C is 17. And angle D is 27. Okay? So, tell me this. What is the biggest side of the triangle? DC is the biggest side, so I'll just put big right here. What's the smallest side of the triangle? DE, because it's across from the 17, so I'm going to put small on that one. That means the other one is like the middle size, so I'll just put middle. Now, I'll analyze these choices and see which one is true. I'm looking for one that's true.
Do you have to write it like that? Because I didn't write it like D. I didn't like put the angles where you put them.
No, it doesn't matter how you draw the picture. Okay, so is CD less than DE? Well, CD is the biggest one of all, so it's not less than anything. So it's definitely not A. Let's see, is DE less than CD?
Yes.
Well, DE is the smallest one, so it's definitely less than everything. I mean, why was I crossing that out? So the answer is B. That's the one that's true. The other ones would turn out to be false. All right. How can I judge if these could make a triangle or not?
You gotta add the first two up and see if it's bigger than the third one.
Well, make sure that the third one you're talking about is the biggest. It's all about which one is the biggest. Did they put all these in order? Okay. So in this case, that would work. But make sure we're talking about the biggest one, okay? He said, look at the biggest number. In this case, 26. 26 is the biggest. Okay? The other two have to be more than that. All right? What's 15 plus 18? 33. Okay, that's bigger. So that could be a triangle. That one's okay. This has to be bigger, and it is. So the answer is A. Let's just look at one other by contrast. The biggest is 32. But then if we look at 16,
It's 33. Oh, they're supposed to be bigger than that?
they're supposed to be, the two other sides have to be more than the biggest side.
Oh.
It has to be bigger. So for example, if we look at B, the biggest one is 32. Then if I look at the other side, 16 plus 16, that's only 32. Those are equal. They're not allowed to be equal. The pair has to be bigger than the 1. So that would be a no for that reason. And if we check the rest, we'd find out that the pair is not bigger than the biggest. So A is the right answer. Any questions on that? Did you follow that? Look at number 7. The first 3 angles in a pentagon have the same measure. I don't see any pentagon, so what am I supposed to do? Draw it. Everybody draw a pentagon right now, best of your ability. Okay, there's my pentagon. It says the first 3 angles all have the same measure. Okay? So since they have the same measure, I can just call it x. X, x, x. First 3 angles all the same. But then the other 2 angles have a measure of 10 degrees less. So what expression will I use for those? I will use x minus 10. Now, to make an equation, it would be helpful to know the total degrees inside of this figure. We already did this on problem number 1. So look back at problem number 1 and tell me the total degrees. Looking back at problem number 1, the total degrees was 540. One more time, we got that. We got that by doing our formula n minus 2 times 180. Okay, we got that by doing 5 minus 2 times 180. Okay, so once we have the total degrees, we can make an equation. Let's just add everything up. Look at the x's. X, 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 x. How many x's do I have going around the sides here? Total of 5, including the ones that are part of the x minus 10s. I'm combining like terms, so I have 5 x's. So that means I have 5x. But then I still have this minus 10, minus 10. That together makes minus 20. Do you guys understand why it's minus 20 and not 0? Because if it said minus 10 and then plus 10, that would make 0. But since they're both the same, they make negative 20. And that should equal a total of 540. So it's just a matter of solving this little equation. So let's add 20 to both sides. That gives us 5x equals 560. And then let's divide both sides by 5. So I get x equals what?
112.
X equals 112. So there it is. We were supposed to find the measure of one of the first 3 angles. That was my x, so that's 112. That's why the answer is C. Okay. Let's remember about proving triangles congruent. We learned 5 ways to prove triangles were congruent. Side, 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 angle, 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 side, and hypotenuse leg for right triangles. Note that angle, angle, angle does not prove that 2 triangles are congruent. Neither does side, side angle. That's the one that could be a bad word, right? If we wrote it the wrong way, that helps us remember that that one doesn't work. Thank goodness for teachers. Bad word 1 doesn't work, so we can forget about it. So, let's go through each of these. Have you guys had a moment to do this yet? Okay, let me pause the tape so you can do it. All right, for A, show me on your fingers what you guys put for A. Remember, hold up. Oh, wait, I didn't make that clear. Oh, wait, let me pause it. All right, the finger thing is not going to work. We're just going to blurt it out. So what did you guys put for A?
Side, side, side.
Side, 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 because we're counting the shared side as one of the congruent sides. What did you guys say for B? That's going to be none. There are no sides that we know are congruent. We know that this extra angle is congruent. That's all we could prove. But angle, angle, angle is not one of the ones that works. So that's a none. What about C?
Side angle side.
Side, angle, side. What about D?
Hypotenuse leg.
Yeah, this is a right triangle, so hypotenuse leg is an option. And we do have hypotenuse and leg marked, so hypotenuse leg, HL. What about E?
None.
That's another none. If we tried to do it, it would have been side angle. But again, that one it doesn't work. So that's none. What about F?
Angle side.
Angle, side. We know that these angles are also congruent. Angle, side is correct. I'm curious, how did you know that it was angle, side and not angle, side, angle? Because that
Can't be an angle side.
angle, side, angle is a choice. And they both involve two angles and a side. So how do you tell the difference between angle, side?
It's gotta go consecutive.
It has to go consecutive.
Right, if it was going to be, I'll just draw a one triangle example. If it was going to be angle, side, angle, we would need an angle, a side, and an angle. Basically, the side would have to be between the angles if it's going to be angle, side, angle. All right, look at number 9. Okay, which relationship is sufficient to prove that these triangles are congruent? Well, let's just mark things on this triangle as we go. So PR is congruent to SU. So this would be PR.
Are you gonna count off if we don't mark on it?
Yeah, I should see some kind of marks. That's a good question. PQ is congruent to ST. So PQ is congruent to ST. So far, so good. Could be something. Angle Q is congruent to angle U. Whoa. That's no good, is it?
It doesn't even look right.
It doesn't even look right. But they could say drawing not to scale. But still, if it were going to be something, this would be side angle, which is not a choice. So A did not work out. That's a no. Okay? Look at B. Let's erase my marks real quick. Okay, looking at B. PQ, PR. Whoa! That's not even on two different triangles. That's on the same triangle. That's not going to help us prove anything congruent. I don't even need to look at the rest. That's a no. Okay, let's look at C. Erase my marks. Let's see, RQ and TU. RQ, TU. So far, so good. Angle R and angle U. Angle R, angle U. Even looks right, doesn't it, Mr.
Can there
Sawyer?
be more than one option?
That's a negative. This is a multiple choice question.
That's a negative.
And then angle P and angle S. Angle P and angle S. That sure looks good. Is it one of our patterns that works?
Yeah.
Which one would it be?
Angle,
This would be angle, side. Again, can you tell why it's not angle, side, angle?
Yes.
What would it look like if it were going to be angle, side, angle? The side would have been in between. Let me show you real quick. This is the true way it is, but if it had been like this instead, if these had been the sides that were marked, then it would be angle, side, angle, just so you know. Anyway, the correct answer is C.
But like, doesn't D work out to you?
Yeah, D, I'm seeing, just even at a glance, I'm seeing angle, angle. That one's no good. Okay? And look at number 10. Which of these can be proved using hypotenuse leg? Let's just take it one piece at a time. Triangle PQR. Okay? Triangle PQR would be this triangle right here. Is that even a right triangle, you guys? No, that's not even a right triangle.
No.
So it can't be A. So no, that's a no. What about PTS? Let's see. Triangle PTS. All right, that looks good so far. And triangle TQR. Whoa. Using the Sawyer rule, that doesn't even look right. According to the Sawyer rule, that's going to be no. It just one is small, one's big. It doesn't look right. Well, let's go ahead and prove it. Look at the hypotenuses, for example. See how the PS, that has a double mark on it. Look at the QR. It has a single mark. We know for a fact the hypotenuses are not the same. So that's a no. That's a big old no.
It's D.
I heard it's D. Let's check on through. All right. QPS. QPS would be this guy. Whoops, messed up. QPS would be this. That's not even a right triangle. We don't know this. We can't do hypotenuse leg. It's not a right triangle. So it's not C. Well, it must be D, because that's the only one that's left. But let's follow through and see why it's correct. Let's see, QTP. QTP is this triangle over here. And then we've got QTR. So that's QTR is this triangle over here. Using the Sawyer rule. Sawyer, do not draw on my board this one. Yeah. They look like they would be the same, but let's look more carefully. I see the hypotenuses that are marked the same. Where's the leg, though? I don't see any markings on the leg, so what's up?
It's QT. QT's the leg.
QT is the leg because it's shared. The shared leg is always congruent. So that's it for sheet part 11.